how to solve for the area of regular polygons. Just as a review, remember that a regular polygon is a polygon where all the sides are the same length and all the angles are the same exact measure. So when we're looking at the area of a polygon, I'm going to go ahead and jump down to the bottom here and just write down what the area of the polygon formula is. And it's going to implement something, a term that you are probably not familiar with. But the area formula is 1/2 times little a, which stands for apothem, all right, and then multiply that by little p, which stands for perimeter. So area of a regular polygon is 1/2 times the apothem times the perimeter. So let's first discuss what an apothem is. An apothem is created on this hexagon here. I'm going to go ahead and create a center point, and the apothem is created by connecting the center point of any polygon to one of its sides, but the polygon actually acts as a perpendicular bisector with that side. So this here is my apothem. It's my little a. And the length of that apothem is going to be involved in my area formula. Now, every polygon has the same amount of apothems as it does sides. So I can draw an apothem here, or if I wanted to, I could draw an apothem to each one of the other sides as long as it's acting as a perpendicular bisector with that side. So that's what an apothem is. So when we draw apothems later on, that's what we're going to have to be using and illustrating. The next thing I want you to be able to create is the radius of a polygon. Now the radius also starts at the center point of this specific hexagon. And like a circle, a radius goes from the center point and tries to hit the edge of the circle. In this case, for our hexagon, we're talking about one of its vertices. So this right here would be the radius of my hexagon. Now it has to go from the center point to one of the vertices of this hexagon. That is known as my radius. And we'll show you later how we're going to utilize that radius. Another thing we're going to have to know, and this is a review, is how to find each interior angle measure of a regular polygon. This formula is n minus 2 times 180 divided by n. And remember that n stands for what? N stands for the number of sides. The number of sides. So we will be utilizing that to figure out different angle measurements within these hexagons, and that'll be helpful when we solve for area as well. And the last thing that we're going to have to know, which really there's not a formula, but is going to be the perimeter of a regular polygon, which of course, if a regular polygon, for example, if this hexagon had side lengths of 5, I would multiply that 5 by 6 because there's 6 sides and get 30 as my perimeter. So you're going to have to know how to solve for perimeter of a regular polygon. So let's jump right into example problem number 1. Example problem number 1 says find the area of a regular nonagon with an apothem length of 12 inches and a side length of 20. I'm going to go ahead and put this on here, or take this off of here. I don't know why I put 2 side lengths, but I want the side length of 20 inches. So the area of a regular nonagon with an apothem length of 12 and a side length of 20 inches. So we know that for my formula, I need an apothem and I need a perimeter. This is all my given information. Now my apothem, I know, is 12 inches long. So I'm going to go ahead and say that that is 12 inches long. My perimeter is going to be based on whatever my side length is and how many sides I have. So if I know that my side length is 20 inches, and I'm creating a nonagon that has 9 sides, then my perimeter is going to be 20 times 9, which is 180 inches. So that is my perimeter. So now I have enough information to apply it to my area formula. So I know that area of this regular polygon is 1/2 times my apothem of 12 times my perimeter of 180. So I can either say half of 12 is 6 or half of 180 is 90. Either way, I can do mental math, try to figure out. I'll do half of 180 is 90. So now I have 90 inches times 12 inches. Now I know that 9 times 12 is 108. So 90 times 12 must be 1,080. So my area is going to be 1,080 inches squared. Alright, so that's my final answer. So this was a pretty straightforward problem. It gave you a side length, it gave you an apothem, and gives you all this information, and you just plug that information or substitute it into your area formula. Now let's look at something a little bit more difficult. We're going to find the area of a regular decagon with a side length of 50. So we'll write down again what we need. We need perimeter, and we need an apothem in order to solve for area. Given a side length of a decagon, what does that help me find? If I have a side length, can I find apothem? No, if I have a side length, that helps me solve for perimeter. So I know that my perimeter is going to be 10 sides of my decagon multiplied by the 50-foot side length. So that means my perimeter is going to be 500 feet. So I have my P. Now I'm not given my apothem, so I need to figure out a way to utilize my knowledge of geometry to come up with the apothem length. What I'm going to do on the right side here, and this is something that I want you to do for every problem, is I'm going to create what looks like the bottom part of any type of polygon. Now, angle-wise, it's not always going to match up perfectly, but this is a basic illustration that you can use to get the information that you need. So this is going to be considered the bottom part of the polygon. I'm going to create a point here that's going to act as my center point of my polygon. I'm going to draw the apothem, which we said that apothem goes from the center point and acts as a perpendicular bisector, so it cuts this side in half. And then what I'm also going to do is I'm going to draw a radius. And we talked about how a radius goes from the center point to a vertex. So what have I created here? I created a right triangle. So that means I'm probably going to be using Pythagorean theorem or trig to figure out a missing piece that I don't have. Now, since I know that a side length is 50 feet, and every one of these side lengths is 50 feet, including this one, I'll go ahead and label this as, put a brace here and say this is 50. The apothem is a perpendicular bisector. So that means that when it connects with this side, it's dividing it in half. So this part of my right triangle, from this point to this point, is half of the length of the full side, so it's 25. Now I'm trying to find A. I want to know my apothem. I don't have a value here, so I can't use Pythagorean theorem. I don't have any angle measurements, so for now I can't use trig, but that's where my interior angle measurement formula comes into play. If I can figure out what this angle measurement is of this figure, the radius of any polygon bisects that angle in half. So let's say that this angle here was 120. When I draw this radius, it's going to divide that into 60 and 60. So let's figure out what this angle measurement is going to be in full, and then cut that value in half to solve for that angle measurement that I need for my right triangle. Alright, so what I'm going to do is use my n minus 2 times 180. Again, I have 10 sides because I have a decagon. Okay, so step 1 here is going to be doing 10 times 2, or sorry, 10 minus 2, times 180 divided by 10. So I have 8 times 180, and I divide that by 10, and that gives me 144 degrees. Okay, that means that every one of these angles, that this angle here is 144, and that this angle here is 144. So step 2 is going to be taking that 144 and cutting it in half. Because like I said, the radius is bisecting this angle in half. So that means that this angle becomes 72. Now, do I have enough information to solve for my apothem? Yes. I have an angle measurement and a side length in a right triangle, which means I can now use trig to solve for my apothem length. So that's what I'm going to do. What trig function am I going to use? Do I have something in my hypotenuse? So that means that I do not, so that means I'm going to be using tangent. So tangent of 72 is equal to opposite over adjacent. So opposite from the 72 I'm using is A. Adjacent to 72 is 25. So A over 25. So now I'll be multiplying 25 times the tangent of 72 in order to get my apothem length. So 25 times the tangent of 72 gives me 76.94. All right, 76.94. So that's now my apothem. So that can go in over here on the left-hand side where I'm putting my perimeter in my apothem, so 76.94. So now I can do my area is equal to 1/2 times my perimeter of 500 times 76.94, which is my apothem. So 1/2 of 500 is 250. I multiply that by 76.94, and that gives me a total area of 19,235 feet squared. So we were given a side length that helped us find perimeter. Then we created this illustration and used a couple of formulas we already knew to figure out what my apothem length was, which finished off my area. All right, last problem here on the next page says to find the area of a regular octagon with a radius length of 24. So again, I need my perimeter, I need my apothem. But I have nothing given to me in my problem that's going to help me find either one of these right off the bat. In terms of given, I don't have a side length that I can multiply by 8, since it's an octagon, to find perimeter. Alright, so what I'm going to have to do is I'm going to have to draw that same type of figure again. So we're going to draw a diagonal line, a little base, another diagonal line, create a midpoint or center point of my polygon, create a perpendicular bisector that is my apothem, and then go ahead and draw my radius to create that right triangle. Now, the only information I have is that my radius length is 24. Just like in a circle, the radius of a polygon is going to be the same no matter where it's drawn, the same length. So this is going to be 24 centimeters here. So I need an angle measurement, just like I did in example problem 2, in order to find A. So I'm going to use that same formula I did before, the n minus 2 times 180. The only difference is now I'm using 8, since I have 8 sides. 8 minus 2 times 180 divided by 8. So 8 minus 2 is 6. 6 times 180 is 1,080. Divided by 8 gives me 135. So that means that every angle of this octagon is 135 degrees. But I don't care about the whole 135, I just care about half of it, because that's what the radius does. It divides it in half. So 135 divided by 2 is 67.5 degrees. So that's what goes here. So now I'm going to be using trig to figure out what my apothem length is. So I have 67.5, A, and 24. So what trig function am I going to use? I'm going to use sine, because I have something opposite from my angle measurement and something in the hypotenuse of my figure. So I'm going to be doing sine of 67.5 is equal to A over 24. So this is now a multiplication problem. 24 times sine of 67.5 is equal to A. So 24 times sine of 67.5 would give me 22.17 as my apothem. So 22.17. Now, in order to find my perimeter, I need to know what one side length is so I can multiply it by 8, since I have an octagon. So I can find that side length by taking this part of the right triangle and doubling it. So I need to find what this part of the right triangle is and double it to get a full side and then multiply that by 8. Now, one of the issues that I have right now is I need to figure out what I'm going to use. I'm going to use trig, or what's the other thing I can now use that I know that A is 22.17? I can now use Pythagorean theorem. But I still think trig is faster. So the last step I'm going to do is use cosine to solve for what I'm going to call just x. Cosine to solve for x. So cosine of 67.5 is equal to a over 24 again. So I'll be multiplying 24 times cosine of 67.5. I'm going to get I put x here, not a. I want to put an x. I'm not looking for the apothem. I'm looking for x. So my x value is 9.18. That gives me half of one side. So this number now needs to be doubled to get a full side length. 9.18 gets multiplied by 2 to get a full side length. Then it gets multiplied by 8 to get the full perimeter. So over here on perimeter, I'm going to say that 9.18 needs to be doubled and then multiplied by 8, because that gives me a full side length by doubling it, and then the full perimeter by multiplying it by 8. So that final perimeter value is going to be equal to 146.88. Now I have enough information to do area. 1/2 times apothem times perimeter. So 22.17 gets multiplied by 0.5 and gets multiplied by 146.88. So my final area answer for this problem is 1628.16. Alright, these problems are going to have the most work, because in the other problems I was given something. I was given something that helped me find perimeter. I was given something that helped me find, that was just given my apothem. But if I'm given the radius length, I have to find both things. So it's going to take a few more steps to get to that point. Alright, a couple things. You need to have this watched obviously by Friday. I got these at Tom Thumb the other day, and if you're looking for a new good snack, they're in the produce section. Snap Pea Crisps. These are actually the wasabi ranch flavor. There's a bunch of different flavors there, but those are on sale, so I highly suggest. These are actually pretty healthy for you. Good source of fiber, it says. So yeah, if you're looking for something to snack on, that's a good option. So have a great rest of your day, whatever day this may be, and praying is out.